Okay guys, in this video segment we're going to talk about accuracy versus precision and how those terms are the same and also how they have some differences to them. So when you look at the word accuracy and the word precision, typically a lot of people will use those two terms interchangeably in your everyday speech, which is okay, but when we get into the world of science we really need to start to take these two terms and break them apart a little bit and actually look at the two differences between these two terms. So the first one we're going to talk about is precision. So according to our notes, precision is how close the measurement is to other measurements. So when you're looking at precision, it's how close did you get versus somebody else versus another person, or if you take multiple trials, how close are your individual trials to each other. Now that can be done in two different ways. So for example, if we go to the board, if I'm measuring off of a balance and I'm getting 5.3, then I get 5.5, and 5.4, and then a 5.1, and I'm measuring a certain mass multiple times. My precision here is limited to this tenths place, and the closer that these numbers align with each other, the more precise I am. So for example, these numbers are, the precision goes out to the tenths place, and the range between them is somewhere between 0.1 to 0.5. So it's kind of like my range within my precision. However, a person who comes in and uses, let's say, a different balance, a more precise one, and is getting measures of 5.31, 5.25, 5.33, 5.37. If you look at this series of numbers, the precision of these numbers are going out to the hundredths place. So because they're being measured out to the hundredths place, they're more precise measurements. Now the range between those goes anywhere from 5.25 all the way up to a 3.7. So from 2.5 to 3.7 is our range there. So you see that the range is also tighter. Now typically, the more precise you measure, the smaller your range will also be. So what you're looking for is out to the farthest decimal places you can go, whichever your measuring tool allows you to do. And then also, how much different is it between your lowest number and your highest number. So you want to have a small range, and you want to go out to as far as possible to increase your precision. Accuracy takes that idea and doesn't really care so much about the range or how precise you measure it. It actually looks at how accurate or how correct you are with your numbers. So if you take all these numbers and you average them out, and if the right answer should have been 7.6, these numbers are not going to be anywhere close to the right answer. So that would be an inaccurate measurement. However, if the right answer is 5.32, let's say, if we know this to be the true value, this is a pretty good set of measurements because we're somewhere in between 3.7 and 5.2, so somewhere in the middle there. So our average here, if I actually average these three numbers, are going to be pretty accurate. Okay? Same thing up here. If I average these numbers, still going to be pretty accurate, not as precise, but still pretty accurate in terms of what we're talking about. Okay, so an example for us to work with is if we take a look, we have Bob here and we have Frank, and Bob and Frank both made measurements, and there's their 5 trials, and there's their averages. Okay. They both measured to the same precision in terms of which decimal they measured to, but let's take a look at their range and see who's more precise. So who's more precise here? Well, let's see. Frank goes from, looks like a 5.3 all the way to a 5.8, and Bob is from a 5.2 to a 5.4. So because Bob's range is smaller, even though they measured to the same decimal, since Bob's range is smaller, Bob is more precise here. Now, who's more accurate? So, okay, we take a look at the numbers. Bob's being more precise, but Frank, 5.52, we really don't know the answer to this question until we find out what the right answer is supposed to be. So if you could look up the known for this, or if there's a given value that you're targeting, if we knew that, so for example, if we knew that the correct value is 5.58, looking at these two numbers, you could say, wait a minute, well, Bob is being more precise, Frank is closer to the correct answer, so Frank is being more accurate between the two. Now, in comparison, what's better? So is it better to be accurate but have poor precision, or is it better to have great precision and poor accuracy? Right? The reality is, when you compare these two things, to have a quality measurement, you really want both. So there isn't one versus the other. In terms of fixing mistakes, sometimes it's easier to fix a mistake of accuracy versus a mistake of precision. So for example, if I'm playing basketball, I was a horrible basketball player. I remember middle school basketball, I couldn't make a free throw if my life depended on it. Well, I could make a couple. Anyway, my coach one day came over and he saw me just completely bricking him off the left-hand side of the basket the whole time. So what did he say to do? He looked at me and says, "Why don't you take a step to the right?" Kind of made sense to me. Every one of my shots was going left, so I took one step to the right, and then I made like 3 out of 25. So I tripled my results there, which is pretty good. So he fixed my accuracy. I had decent precision. I was hitting the left-hand side every time. I just wasn't being very accurate. Okay. So the reality is, when you work with lab stuff, you want high precision. So you want your numbers to agree with each other, but then you also want those numbers to be close to that target or that correct answer, which is accuracy. Okay. So similar verb, similar terms, but they are used slightly different. And I will use those throughout the year. So I talk about the precision in your measurements versus how accurate your results are going to be, and we'll use those accordingly. Okay, guys, that ends this segment on accuracy versus precision. Thank you.